Solve the equation. 12 parentheses 10 minus 7 parentheses plus 9g is equal to g parentheses 2 squared plus 5 parentheses plus 36. The first step to solving an equation is to apply PEMDAS. The P in PEMDAS is parentheses, so we want to evaluate the expression within the parentheses on the left side of the equal sign, and also the expression in the parentheses on the right side of the equal sign. On the left side, we simply have a subtraction, so we can execute the subtraction. On the right side, we have an exponent, which is what we want to do first. So let's rewrite the equation. 12 parentheses 3 plus 9g is equal to g times 4 plus 5 parentheses plus 36. The parentheses on the left side can no longer be simplified. The parentheses on the right side of the equal sign still has an addition to be executed. So let's go ahead and add 4 and 5. And let's also multiply the 12 and the 3. This will leave us with 36 plus 9g is equal to g times 9 plus 36. Now we want to apply PEMDAS on the left side of the equal sign, but we can't because there are no like terms. Like terms, remember, have the same variable with the same power. So these two are not like terms, and we cannot simplify further. The right side, we have a multiplication to perform. So let's go ahead and do that. 9 times g plus 36. Now that we're here, we want to get the term with the variable alone on one side of the equal sign and the constant on the other side of the equal sign. So I'm going to start by moving this 9g to the other side of the equal sign. I'll subtract 9g from both sides, and that will leave me with 36. I get a 0 when I add 9g, and negative 9g is equal to 36 because I get a 0 when I add 9g with negative 9g. We have a constant is equal to the same constant, and this is an identity, and our answer is all real numbers. I'm going to put a box around that. Let's move on to the next equation. Again, we need to run PEMDAS on the left side of the equal sign and also the right side of the equal sign. And we have parentheses as our highest order of operation. So we are looking at this expression, and that expression. Inside of this expression, the exponent has the higher order of precedence, so we will do 2 to the power of 3 first. In the second parentheses, we have a subtraction, and in the third parentheses, we have a division. So let's go ahead and do all of those math operations. 2d plus 8 minus 5 parentheses is equal to 10 parentheses 3 plus d parentheses 2. So we still have a subtraction in the expression in this parentheses. We can perform the subtraction. Here in this parentheses, we can't simplify any further, so we'll leave those two alone. Let's rewrite our equation. 2d plus 3 is equal to 10 times 3 plus d times 2. Looking at the left side of the equal sign, we do not have like terms. Same variable, same power. This term has a d, and this term does not have a d. So the left side is simplified. The right side, we have a multiplication and another multiplication. Let's go ahead and perform those multiplications. Two d plus 3 is equal to 30 plus 2d. The left side of the equal sign is simplified. The right side of the equal sign is also simplified. So now we need to get the term with the variable on one side of the equal sign, get it alone, isolate it, and the constants on the other side of the equal sign. So I'm going to start by subtracting 2d from both sides of the equal sign. When I do that, I get 0 on this side, leaving a 3 is equal to 30. Now 3 is not equal to 30. I'm going to put a line through the equal sign, signifying that 3 is not equal to 30. And the answer here is no solution. So we can say no solution, or we can say empty set. A 0 with a line through it. So let me go ahead and box this answer. Why don't we move on to problem number 3. We can look inside of the parentheses and we can see that we cannot simplify anymore. So from there, the next highest order of operations is the multiplication. The negative 1/2 times the difference of c and 6. So let's go ahead and distribute out the negative 1/2, leaving us with 5 minus 1/2 c plus 6 over 2 is equal to 4. You need to remember that we are distributing outing the negative 1/2, not 1/2. So it's negative times a positive is negative 1/2 c, and negative times a negative is positive 6 over 2. I'm sorry, negative 1/2 times negative 6 is positive 6 over 2. Alright, so from here we can simplify this fraction. So let's do that now. Let's combine like terms on the left side of the equal sign, and we have 2 of them, the 5 and the 3, leaving us with negative 1/2 c plus 8 is equal to 4. Let's get the term with the c alone. Let's isolate the term with the c by moving the 8 to the other side of the equal sign. Let's subtract 8 from both sides of the equal sign. This leaves us with negative 1/2 c is equal to negative 4. Now to remove the negative 1/2 in front of the c, we can multiply both sides of the equal sign by the reciprocal of negative 1/2. Let's do that now. So when you multiply a fraction by its reciprocal, we get positive 1. So negative 2 over 1 times negative 1 over 2 is equal to positive 1c. That leaves us with c, positive c, is equal to negative times a negative, let me put a parentheses here, is positive. And when we multiply 4 times 2 over 1, we get 8 over 1. 4 times 2 over 1. 8 over 1, which is simply 8. And I could put a box around that.